The PDF for a continuous random variable is stated as f of x is 0.5x take away 3 for x between 6 and 8 and 0 otherwise. We want to find the CDF and use it to calculate the probability that x is between 6.5 and 7.5. Okay, so let's get a picture of what this looks like. This is not absolutely necessary, but in trying to explain it, it helps. So we've got x and we've got f of x up here. And when x is 6, this would be 3 take away 3, which is 0. So at 6 it would be there. And then at 8, that would be 0.5 times 8, 4 take away 3, which is 1. So if we say this is 1 up here, and this is 8, then what we've got is a line that goes like that. And so if we just go over that with the line of blue here, and so we can see that the PDF looks like this. It's 0 back here. This is a non-zero section, and it's 0 from there onwards. So this is some value x that's in this region, then the green here represents the probability that x is less than or equal to x, which of course is what we call f of x, capital F. Okay, so what we need to do is we need to integrate between 6 and x, 0.5 t take away 3 dt. And I make the same point here about the variable as I did in the last example. So that's going to be 0.5 t squared over 2, which is 0.25 t squared, take away 3t, to be evaluated from 6 to x, which gives me 0.25 x squared minus 3x when I use the top limit, and with the bottom limit we've got a quarter of 36, which is 9, take away 3 times 6, which is 18. So that ends up being 0.25 x squared minus 3x. Now that will be minus 9, and with this minus as well, that's going to end up being plus 9. Now, to make sense, of course, that has got to be 0 here and 1 here. So let's just check that. So I've got 0.25 times 6 squared, take away 3 times 6, add 9, and that is 0 at the bottom end. And then if we can just go back into that and replace the 6 there with an 8, so there as well, and this should come to 1, and indeed it does. So that does all make sense. I always like to check. And so what we now have is that capital F of x is, well, that's going to be 0 when x is less than 6. It's then going to be 0.25 x squared minus 3x plus 9, and that's going to apply if x is between 6 and 8. And then once we've got to the maximum probability of 1, anything above, the probability of being less than 9, for example, is going to be 1 as well. So it's going to be 1 for anything more than 8. So now we want to use our CDF to find the probability that x is between 6.5 and 7.5. We consider f of 7.5. That's going to be this area here. We think about f of 6.5. That's going to be this area here. Now if I do the big area, the big yellow area, take away the red area, I get left with this area here, which I probably should have done in a different color, such as green. And that's the area that we want. So what we're going to do is f of 7.5, take away f of 6.5, and we can just calculate that. And I've done this calculation here, and we can see that it comes to a half.